Okay, it's 1 minute after 4. Good afternoon, everyone. My name is Ursula. I am the assistant in the One Health Boost project that is organizer of today's event. And as you probably know, today we have 2 webinars provided by the experts from the University of Milan. Before we will jump to the topics of the webinar, just short information, what is One Health Boost project. So this is the activity that aims to develop research and innovation excellence and improve the management capacities of Estonian University of Life Sciences. And this learning process is happening thanks to the collaboration with our wonderful partners, which is University of Tartu, University of Helsinki, and University of Milan, that representatives we have today. And on the webinars that we scheduled for today's afternoon, we will touch 2 topics. The first one, behind the scenes of European project research team leadership and collaboration, that will be presented by Professor Fulvio Gandolfi, who is full professor of anatomy and physiology of domestic animals at the University of Milan. And then we will learn more about research communication and dissemination from the bench to the public. That will be presented by Professor Tiziana Brevini, who is full professor of anatomy and embryology at the University of Milan. I'm pretty sure, as it's not our first webinar with the representatives of University of Milan, I'm pretty sure that you will have wonderful learning experience, will get a lot of insights and inspiration how to make your daily work, daily activities better, thanks to the knowledge, experience, and tips shared by Fulvio and Tiziana. I don't want to steal any more space from today's event, so we will start with Fulvio's presentation. So Fulvio, the floor is yours.
Thank you very much, Ursula. That was quite a demanding presentation because I'm supposed to deliver a wonderful learning experience. I hope not to disappoint you all. I see Suranga there. Hi, Suranga, how are you doing? Oops, disappeared. And so today's topic, and now I'll share my screen. And so let me okay, and is this okay? Can you see my full screen? My presentation as a full screen?
Yes, it's perfect.
Mode? Okay. So today's topic is will be a sort of informal presentation, or I will tell you about my experience. So I've been coordinating a European project. I see Ali Reza is here as well. Hi, Ali Reza. And the project is close to its end. We'll end at the 31st of December this year. What I'm going to talk about, it's not about the science behind it, but about everything else. And the first note I will make for those who have never applied or obtained a European project is that all of us, when we try to apply for a European project, are quite rightly 100% focused on the science. But then they gradually and quickly learn that science is just a part of it. And this is in all the steps of planning and obtaining and performing a European project, gradually the non-scientific part will grow, and it can be overwhelming if at the beginning. So you have to get into the mindset in realizing that as opposed to what you are convinced, the science is 99% of it. Science goes down, the percentage, the importance of science goes down slowly with the progress of your work. So I will move to the first slide. So these are the typical step of what they call the life cycle of a project. So the first one is proposal, preparation, and submission. So European projects, as you know, are usually they are based on the formation of consortia. These consortia can be very variable in size. 3, 4, 5 partners can be on the small side. That's the kind of project I've been chairing so far. OH-BOOST is more or less on a similar size. But then there are much bigger projects in which you go for 10 or 20 partners, which I never try to have anything like that, but I can only imagine that it's quite complicated to handle. And indeed, in those kind of projects have a whole session dedicated to that, and a number of personnel involved into it. But usually the first proposers are scientists, and so they focus on the scientific part, as I mentioned. But even at the preparation, at the submission part, you will follow the format for each program you are going to apply to, and you will see that we will ask specific questions about how you have to provide a number of details that are referred mainly towards the administration of the project, so coordinating the project. Basically all of this I've learned and I understood that come from the intervention of engineers. So engineers have set up the rules, and the European Union follows the rules and the way of working of engineers. And so they are organizational engineers who have invented things like Gantt charts and all this, and this very detailed program of our work. Person like myself are old school, so we grown up developing scientific program which have an aim, of course, and have a more or less a specified pathway to reach that aim. But we were building well, we knew from the beginning that the end result would have been different from what we would expect at the beginning. Because of course, when you perform your experiments, then you learn new things, and the perspective and information changes, and so probably your plan will change. The typical organizational engineering, they don't think about that. They think that everything will go straight exactly as you plan, and so they apply this very strict rule. So you have to describe in very detail what you're going to do. You also have to describe eventually what you can forecast as what can go wrong, and provide ways to overcome these problems, which is a very correct approach. But in the biological field, it was not so common. And now it's becoming more and more common because we are getting more and more used to this very detailed approach of organizing a project. And so this part of organizing a very detailed work plan, organizing a very detailed alternative plans will have an important part also in the evaluation. So as I said, spontaneously we would all be very focused on the science of it, but then the science is also quantified. So if you go in your in the application form and application instruction, you will see how much of each component, how much it will be evaluated. So please read that carefully, and you will see that science has a big part into it, but by itself it will never be able to have you getting a grant. So you have to fill in all the other sessions as well as possible as well. So the first general rule, as I said, everywhere is reading very, very careful the instruction, reading very, very careful the topic of the project, so that you focus your work exactly on the kind of topic they are asking application for. Usually European and nowadays more or less every kind of competitive grant is very competitive. So please make sure to be exactly on the focus of the topic of application. Otherwise, you risk to waste a lot of effort for nothing. So reading exactly the instruction, reading how the project will be evaluated is important in order to prepare all the appropriate documents. And then, of course, if everything goes well, you will get your grant, and then you begin to implement it. And this implies a formal agreement, which is a grant agreement that will be the document that will be your reference document. So whatever you will do, you will have to refer to your grant agreement, and this will regulate your relationship between EU, yourself, EU, and your partners. So there will be your Bible. You have to read it carefully. And the good thing is that you have a chance to have a say when you prepare the grant agreement. So of course, most of it will be already, there is a general format, but you can add little changes that may be helpful in the future. Unfortunately, unless you are a very experienced grant holder, so you have been through this process a few times, you don't even realize that you have this chance, and you realize the impossible advantages many months or a few years later. So as everything, you will get better with practice. One of the parts is the organization and administration. Here, a big difference also is made by your own institution. I must say that during the year, almost every university has realized the importance of this section of their own administrative office, and they're getting better and better at it all the time. Just to give you an idea, when I got my first grant, it was in the early 90s of last century, and I was one of the first of the University of Milan, and they didn't even have somebody who could handle the forms in English. So I had to translate everything and so on and so forth. I didn't know exactly how to handle any European grant. Fortunately, many years has passed by, and now we have a very efficient grant office, and they do all the management. They know exactly how to handle it, and they give you a lot of support in how to organize your application form and how to choose the best option according to the kind of grant and the kind of grant that you actually have won. Basically, this organization administration part of it will regulate how the money are handled. In general terms, the European Union likes to deal with a single partner, which is usually the coordinator. So they will give all the money to the coordinator, who then has to distribute the money to all the partners. This is good and bad in the sense that if you are the coordinator, you have the control of it all. Of course, how it is divided has been decided beforehand. So in the grant agreement that I mentioned, everybody has discussed and agreed upon how much money each partner will have and what the partner will do with the money. So everything is very detailed. There is no much latitude in how you use the money. And you can still make changes along the way, but then is a formal procedure. So you have to ask for changes. Changes needs to be approved, and so you try to not to make too many changes. And therefore, if you are the coordinator, hopefully you will have a good and efficient office. As I said, most of universities now have, and they will handle all the distribution of the money. The other thing is that your institution will also have to coordinate and take care that all the partners provide also a financial report formatted in an appropriate way. So there is a lot of responsibility in being the coordinator. That's why coordinators are not so abundant around. So most people prefer just to be a partner because the amount of work is a couple of order of magnitude smaller as opposed to be a coordinator. But unless you are a very good and sought after partner, the other alternative is to become a coordinator, and so to create your own team and create your own proposal. You have to balance these two competing requirements. There are so all the documents must be formatted in the appropriate way, and usually now all administration have a well-tested format, and they will help you through this process. So the one important aspect, as I said, beside of science, is data and contract management. There are things that likely you never heard about, like data management plan, which is the way in which the data that will come out of your project will be managed and disseminated. The quite right principle behind this, which is although it's painful when you have to implement it, but is quite right and important, is that since you are using public money and you are producing data, this data should be available publicly. This doesn't really mean that you cannot have intellectual property on it, or you have to make public all the data straight away. This is not the case. Actually, quite on the contrary, European Union, especially in the later years, they are quite happy and really are sustaining and pushing towards having this translational research, so having a practical application of the data. So they will help you also in managing your intellectual property issues. So having a management plan, data management plan, doesn't mean to make everything public straight away, but just it means to have some repositories which, if and when needed, can be accessed by third parties. The typical example is when you do a big data project, or like the omics studies, in which you generate a lot of data. These data are stored in a potentially public, well, in a place which is, if necessary, accessible from the outside, in a format which is easily used. So not a proprietary format which will make it difficult for some external party to actually use the data. As I said, it doesn't mean that you have to share all the data straight away, but only if and when you decided that you have made all the use that you need with the data, and then you can make them available. It doesn't make sense to make the transcriptomic of the same tissue 10 times. Once one research group had made a transcriptomic analysis, proteomic analysis of a specific tissue in a specific species, and has completed its own project, then this data makes sense that are available for somebody else in the appropriate form. So then nobody will steal your data, but the European Union will make sure that your data are available at the right condition. In fact, you have project contract with non-disclosure agreements to protect intellectual properties, consortium agreement which regulate what each partner will generate and produce within the project. In our project, we have a material transfer agreement, and so on and so forth. So everything will be regulated appropriately, and they also will both your institution, and also there are a lot of material prepared by European Union that will guide you through this process in order to help you to protect your data, but at the same time make a good use of the public money that have been used to generate this data. This is the consortium agreement that is in place with the project I'm currently coordinating. Let's see if it comes up. So you see it's been signed more than almost 5 years ago, more than 5 years ago. And here there are, so you see, there are the various definition of the various parts, the purpose of the agreement, when it enters into force, duration, termination, responsibility of all partners, liability towards each other. You see the governance structure. For instance, you have to declare how you manage your project. So will be a committee will decide the management of the program. So a more restricted committee and a wider committee who will discuss the details of the program, how you manage the results, how you access the right of access to these results. As you say, as I mentioned, non-disclosure of information. So we can go through. So you see, this is the number, the partners who have been. This is the name of the project, the acronym, and then all the definition, the legal definition. So this is very much a standard procedure. So all this is already pre-written. In most cases, you don't modify it, but go through this carefully. Ask for the help of some professional in your organization, and just make sure that this adapts well to your needs, because every project is different. The aim of the project is different. The type of project is different. So take your time to go through this, because it will affect your work in the following 3, 4, 5 years, depending how long is your project. So these are the various duration, termination, as I mentioned, general principle of the responsibility of the parties. With small projects, this usually you know each other well, and so usually it's not a big deal. But as I mentioned, there are projects with 10, 20 partners. In that case, it's very unlikely that you know all of them very well. It's likely that they are very different partners, so they are industrial partners, academic partners, and they might have a different approach. So we are all academics, so we are used to a certain way of working, but industrial partners have different perspective, and within the industrial partner, you might have, as in our project, we have a very big international corporation, and we have a small startup. So their approach will be different, and you have to understand their needs and make provision of their needs in this grant agreement. As a transfer of material, so you have to declare what is already what you have already prepared and generated before the beginning of the project. So that will be your own property, intellectual property or otherwise. And then there will be new results and new material that will be generated during the project. And in that case, you have to make very clear who will own what. So who will contribute to the generation of a new data or the new invention. And that's, of course, at the beginning was nothing there. Everybody is very friendly, but very quickly things can change if then you begin to invent something, and everybody thinks that They've made a fantastic invention, so everybody becomes very protective about it. So it's better, again, to ask the suggestion and the counseling of some expert and go through these parts before actually you need to, when everybody is calm and relaxed, and you can clearly set out the relationship between the different partners. Ethical and regulatory approvals, of course, that depends a lot on what you are working on. Of course, if you're working with patients, that will be very, very important. Liability toward each other, again, depends basically the topic of your research. Force majeure, of course, that has been, as you remember, in the COVID era, the force majeure has been a major issue. Probably this point has never been regarded much before the COVID pandemic, but after that, it became quite apparent that in some circumstances, this can be very relevant. In our case, for instance, implied prorogation of the contract. So we were starting for 4 years, and we ended up to last more than 5, because during the COVID period, quite a few part of the project was not possible. It was not possible to perform some quite important part of the projects. And what I mentioned is the governance. So the general structure, there is a general assembly, and then there is described exactly how you convene the assembly, what each kind of assembly will decide. And so it is described in detail the kind of ways that this assembly will operate. Again, the COVID made a big change in all of this. Before COVID, most assembly, the most common way was to get to meet in presence with the pros and cons. Of course, in some aspects was much better to have a meeting in presence. On the other hand, they were more expensive, and you could do that only from time to time. Now we all learn much better, as we're doing now, to work from remote and to interact with each other from remote. And although for many aspects this is less satisfactory, on the other hand, it gives you the chance to get many more meetings and getting together more often and in an effective way. So this is the notice of the meetings, the agenda, adding agenda item, and so on. So it's very detailed. Voting rules and quorums. So like so as a departmental meeting, veto rights. So everything is very well described, and so you have to read it through and comply. The duties of the coordinator, the management committee, as I mentioned, should be in charge of implementing the work program detailed in the proposal. So especially when some problems arises, we had to do, as I mentioned, we had to do some trials that were not possible to be performed due to the COVID. So we had to decided what to do, if change the program, if just postpone the program, or find out some alternatives. And everything was managed by this regulation. And so you find this kind of documents online with the general principle, and then as I mentioned, you can put some changes and make it fit properly to your own needs. The topic of your research and the kind of project will make a lot of difference about it. Dissemination, you see, it's important, is an important part of your project. Dissemination of your own results, because this is another point in which the European Union is becoming more and more sensitive. So we received quite a lot of money from the European Union, and they now they want to be sure that people know that we receive money, that we do something useful with the money. So the dissemination part of the project has become much more relevant than they used to be.
Fulvio, can I interrupt you for a moment?
Yeah.
I'm not sure, because we see the same slide, this consortium agreement, and I have the feeling that you are talking about other elements already.
Yeah, I thought it was I was
or
showing...
it's covered by this one slide all the time, just to make
Oh,
clear.
sorry. Let me check out. No, I was scrolling through a document. Let me...
Okay. So then, no, we saw the agreement.
So you're not seeing this. Where is it now? Let me... sorry, let me understand how it works. Okay, so let me try again. So maybe I should share another document. Let me... Oh, I'm sorry. I was talking about...
That's okay.
Can you
Just
see?
now, when you started to talk about this,
Okay, so this I was scrolling
I
through this
realized that,
document.
yeah.
I'm sorry about that. Basically, I was showing the document that which you see the first pages. I was goes through the document.
Okay.
So you can see, as I mentioned, you can find an empty document like this easily online, and then you add your own details of your own project. Okay, so I go back to the... let me... Okay, so I'm the sharing part. Okay, now I go back to this. Okay, I'm back to the slide. All right.
Yeah, we see the slides.
Okay, so
finances and reporting is here.
Okay, so as I said, this financing and reporting, as I said, this will be the coordinator will bear most of the weight of this. Each party will have to provide a financial report, but the coordinator will have to put them all together and make sure they are prepared in the right way. And there will be project officers, so people who will evaluate your project. Some of them will be European administratives with people with administrative experience, and some of them will be academic evaluators. So they will go through your reports, both financial and scientific, and make sure that the two fit together well. So you spend the money as you planned, and above all, which seems to be obvious, but it's not always the case, that you spend the money progressively at the right time. So people is always worried not to have enough money, but most of the trouble come in the sense that people don't spend all the money they have. It seems strange, but that's what in most cases, most of the issue arises because people have not spent all the money they had for a specific task. It's more rare that they overspend. So that should be planned carefully and that given enough attention, enough details attention about that. Continuous monitoring and risk management. So the project will be monitored continuously. I will show now you a couple of slides how you actually do in practice. And risk management. So as I said at the beginning, we expect that hardly ever things goes as planned, because otherwise it means that your project was not really well. If you already know how it ends, it means it's not very innovative. But you already knew exactly what kind of result you would expect, and at least in my opinion, this is not really a very good project. It means it was so obvious that you don't learn very much. So in most cases, you will obtain different result of what you plan, or different problems of what you plan. So you thought that maybe some part would be difficult and they go smoothly, and the other way around. Some parts that are supposed to go smoothly, then they create a lot of problems. And you have to take care of this problem. So you have to recognize them. So you can change your plans as long as you explain why, and above all, how you make how you go through the problems. And as I said, this is a little bit, it takes a little bit of bureaucratic efforts. So you have to change the agreement that you've signed that I showed you before. And especially your work plan needs to be changed, and in a detailed way. As I said, this is the engineering influence of it all. Most of the people, so biologically oriented as I am, are not so used to such a level of detail. We prefer to have a little bit more flexibility, but the European Union doesn't like all that flexibility. So you have to be pinpoint. It's a good exercise, actually. So you have to pinpoint exactly what creates the problem. You have to explain clearly how you want to solve it. And the way you do that is that you have this portal. You see, this is our project, and you click manage project, and you enter in another screen, and you see project monitoring for consortium. So you have to, here there's a continuous reporting. So you can add, you add all the, you have planned a number of deliverables. So you have for a regular interval, you have a list of deliverables to be submitted. So you have to upload this deliverable in the appropriate format. You have to upload the milestone that you have planned and you have reached. Or if not, you see, you have this in the somewhere here, sorry, now it's not live, it's just a slide, it's a screenshot. So you can open here and you can have you can add the modification to the grant agreement. So there is all a procedure. So everything is submitted through this portal. So you have to ask to your contact, to your project officer to start the procedure. You have to upload all the documents where you explain what you want to do, why you want to do it, and they go through different offices, and they ask the consultancy of your academic evaluators, and they evaluate if the changes you propose are sensible, and if they're suitable for solving the problem. So this is a kind of where you upload. You see, these are the deliverables, the list of deliverables when they were supposed to be uploaded. If you upload that, if they've been approved, if they've just been submitted, or you still have to upload them. And then you have the critical risk that you have to upload. You upload the publication while you every time you prepare a publication, you upload them. Dissemination and communication effort, you go there and you insert where you have disseminated your results, with kind of meeting or activity, how many people attended it, and you see intellectual property rights, innovation. If you have small, medium enterprises, how these projects have impacted them, and so on and so forth. So it's a big portal in which you have to upload all the results, all the ongoing details. and you will also every number of months you will have to. We went through 2 evaluation meetings, and we will go through the final evaluation meeting in a few months' time. And there is a very big exercise, so you have to prepare a very detailed reports where you assemble together all the deliverable, and you do a critical evaluation of your results. So in most cases, as I said, well, in every cases, European projects are based on collaboration, which is good and bad. It's a long time now in which a single researcher could have a specific grant who could handle just by him or herself. So many years ago, that was the most common way of getting funded. So you applied for your own grant and you were working by yourself or by your group. Now this form is getting rarer and rarer, so it's always a collaboration effort. So that implies to learn the skill of collaborating and to organizing effective consortia, which is based, as I said, on detailed planning. That's why all the engineers come into play, and we have to adapt to it. Probably we should also improve the way in which these skills are taught also to our younger colleagues. So biologically oriented, life science oriented scientists, they should also learn some management skills that will be useful when they apply for grants. And so there are the EU project have a very large budget, so that's why it's very difficult to get them. On the other hand, when you get one, then you can work nicely for a few years. So it's a long-term commitment between 3 years and onward, between 3 and 5 years, more or less. As I said, on the other hand, there's very many forms of grants. I mentioned in another seminar the EIC kind of grants. So those are mostly aimed at translational research, but there are many different type of grants. So go through the potential list and try to understand which is the best option for you, and then begin to build your own network. Actually, it's very wise to build networks anyway, because as I said, now is almost not existent anymore. The option, or is very limited, the option of having single lab grants. So you have to apply together with other colleagues, either nationally or internationally. So it's a small piece of advice is to build your own network and being able to build it and to keep it alive, even not in the immediate proximity of a grant deadline, but build up a collaboration in advance, so you're ready to take advantage of some call for application, and the network building is largely already being created. Another thing is that we tend to get in contact with colleagues that do very similar things, obviously, because we share the same interest. However, it's again wise to have a wider perspective and keep in contact and get in contact with people with not with exactly the same expertise, but maybe with how do you say, with expertise will integrate with yours, so not exactly the same, and so that you are in a better position, because one of the widespread quality of grant application is interdisciplinarity, so solving a problem by tackling it from different perspectives. And these things work better if these groups are being formed slowly with time, and not just in a few weeks before the grant deadline. So begin to think about and getting organizing in applying for as consortia, as groups, and prepare about the formation of the group beforehand, before the actually deadline, before the actually grant gets advertised. Of course, then you have to make some arrangement, but as I said, the network should be already there. And I think that was more or less the last slide. And so I stopped my sharing, and I'm available if you have some questions, or anyway, thank you very much for your attention.
Thank you very much, Fulvio, for a very comprehensive presentation and sharing your experience. So now the stage for the question is open. If anyone is ready and has a question, please raise your hand or write in the chat. Ali Reza, please. You are muted.
Thanks, Ursula, to tell me. I was just saying, thank you very much, Fulvio, for very nice presentation and telling us about your experience. Well, and I know you are also now getting also involved with other kind of grant applications, if I can say so, that are involving industry or maybe capital ventures and so. And are they also, you are doing that with the European Union, or is it completely a different story?
Well, we're doing both. So as I said, that the kind of grants that we have applied to, this EIC, what they call EIC grants now, there was a FET Open grants before. I receive, and I've been receiving a mail encouraging me and all the partners to take advantages of this transition grants, transition initiatives more than grants, in which they provide the training for academics to explain how to try to move from the laboratory work into a more applied application. So you have a nice scientific results that might have some practical application. They organize these courses in which they tell you how you can, what that will be the first steps from moving from one approach to another. And so the European Union is very active on that. They organize this. So we just took part to one of these training sessions last week.
Mm-hmm.
And so you get involved in the fantastic world of pitches. So you have to learn how to present your idea in a short, concise way to potential investor or potential people who like to help you in trying to move from the lab to the real world. I must admit that I was surprised of how many of these initiatives are available, both through the European Union, in many cases through national initiative, and private initiatives. So there is quite a bit of money available for this sort of things. So there is sort of appetite in translating research into something more applied, what is called a spin-off or small enterprises. You need to go through a very some interesting change of perspective. Of course, there are other things that become more important as opposed to just a traditional research grant. So it's important that you have some practical applications, that the results are reliable, they're repeatable, and maybe the science is not so exciting anymore in certain extent, so you don't go, I think, completely new. But on the other hand, I think it's also satisfactory because they go on things that you have to prove that your research actually is useful to do something. So it's not just interesting data for the sake of a few aficionados or very specifically interested people, but as a wider application, and can really give results to outside the lab. And as I said, there are many initiatives that the easiest thing to get access to is training. And of course, a little bit more complicated is moving from the using this training to get money. And but it's definitely not more difficult than getting research money. So it's competitive, of course, but the success rate is at least comparable. If you have something which is, of course, meaningful that you can somehow apply. And again, you have to change your perspective, try to understand how your result can be applied in the real world, and propose that. Maybe it's the first time you don't get it right, so you move and you try, and more you get into it, and more you learn as everywhere, as every time. So yeah, I think it's definitely a good alternative, especially in a time like ours, at least, well, in our country, but I suppose in most countries in which the nice, reliable university position are not so easy to come along anymore. And so this hybrid position, half research, half entrepreneurial, might be a good alternative. And I think also that in many universities, they quite like to have people jumping from one side to another. So being applied on one side and being a researcher on the other side, and move from one to another. And also it will be reflect positively in your teaching ability, because as I mentioned, now also young people need to be more flexible and learn to do both sides.
Thank you very much. But what do you think, that it is more chance of success there, or you don't think that it is anything more than what the traditional grant applications?
Well, really depends. Again, you have to do a lot of research work. You have to find out, because now there are in group of investors very specialized. So there are generalistic group of investors that, but this is a sort of kind of investors that are decreasing. They are very specialized group of investors. So depending, it's very likely that whatever you are working on, there will be a group of investors interested in your area of research. And then, of course, depending on your research, which is basically the same as the research grants. The difference here is that, but it's, I must say that now even a research grant, and nobody is interested in basic research without any already foreseen kind of application. Actually, the two things are, in this respect, are converging. And if you get yourself trained in highlighting the potential use of your research and your results, it will be useful also for traditional research grant, because in most research grant application, you have to somehow indicate why you want to do this research, which are the possible application. So pure research doesn't exist anymore. And all of us have to indicate more or less clearly what your research is, which is the purpose, which is yeah, I mean, I think it's correct. So at least having the perspective, it's true that there is this idea, more or less romantic idea, that you do research for the sake of it, and sometimes it will come up something useful out of it, which is actually happens. But at the same time, so you try to research for something, and then you come up with something else, and then you can apply that for something that you didn't expect at the beginning. So I think that the boundaries are very flexible, and I wouldn't really get fixated about having pure research as opposed to applied research. The two things evolve in parallel, and I mean, a good research is a good research. So it's if you provide useful data, they might be useful directly per se, or for something else that you didn't think about it, or they will allow somebody else to go, or yourself to go towards and apply. So it's the two things are much more communicating that in theory that we think of. And as I said, there is a surprising amount of money available for that sort of application, provided that you get into the correct mindset. So you realize that your research can have a practical application, even if it's not immediately. So people are willing to pay for the development and to support you for the development. It doesn't mean in any way that you become rich at all. The maximum you can aspire is to get, as I say, your salary exactly as the research grant. So your salary and some money to work with. Don't think about having a startup like the high-tech startup becoming a billionaire in 2 years. Well, surely not for the kind of things I'm working on, maybe some other topic.
Yeah, I like your expression of romantic idea of research. Thank you very much.
Thank you very much for sharing romantic approach. Exactly. Do we have any other questions? If not, then thank you once more, Fulvio, for an insightful presentation.
Thank
so
you.
We got the overview of project management collaboration, touching different aspects of this. And now I think we are ready to jump to another one, which is communication and dissemination of what we do in the projects, how we are visible, how we are seen outside. And about this, we will learn from another expert from University of Milan, from Professor Tiziana Brevini. I hope that Tiziana is still there and can share her experience and knowledge. Yes, as we see, the presentation is ready, so I'm giving voice to Professor Brevini. It was okay just a moment before we had this presentation mode visible.
Yeah, just sorry, I'm muted. So here I am. Can you hear me?
Yes, we can hear you. We see your slides. Yeah, now it's perfect.
Okay.
Super.
Thank you. Sorry about that. I didn't realize I was muted. Well, good afternoon again. My name is Tiziana Brevini, and I would like to start this discussion with you by stating that I am a scientist and I'm not a media manager. But along my career, I sort of understood that we need not to overlook the aspect related to dissemination, and to try and understand what really people understand or feels about our activities as scientists. And this makes a difference, and I hope I will convince you about this in my talk today, and I would like just to provide you with some example about that. Right. Basically, the trend in behavior of most scientists is to keep themselves to their laboratories. So we sort of don't like to move from the cloisters of academia into the public. And in general, this implies cost, not physical costs, but costs related to what we tend to look at as a waste of time that we would rather dedicate to experiments, manuscript writing, grants writing, instead of trying to find a way to communicate, to explain what we do, and to basically get exposed to the public sphere, which also can represent or can somehow raise criticisms by our colleagues. So there are a number of aspects that tend to prevent an open attitude from the scientists to the general public. But the question is, what do the people think about science and scientists? Which basically translate is in what do people think about us and about what we do? And what is their general feeling about what we do? And how do they judge our activity? And this is in general important, but becomes particularly important, especially when dealing with somehow controversial issues such as cloning or, dealing with embryos, manipulating embryos, or transgenesis, and aspects that may raise interest and a general criticism from the public perspective. Well, something that you're probably, or some of you may not be aware, is that the European Union uses different approaches when deciding how to allocate money. Of course, they contact specialists and experts in certain fields and try to explore the potential interest of certain area of research and so on. But another way they use, another approach they use, is the use of the so-called Eurobarometers. And Eurobarometers are survey, and they exist in different variations. But in general, Eurobarometers tend to collect opinions from the public, from all the countries that belong to Europe, trying to understand their interest, their trend, and if they would agree to readdress money to into a certain direction versus another one. And so basically, in a way, scientists have a full interest in somehow influencing these Eurobarometer decisions, because this will result in the end in addressing or moving fundings in one direction or the other one. Eurobarometers have been carried out in several options. We have had some quite old ones, and these are the title which I mention here for your interest, but they are all addressed to the idea to understand what is the general perspective of big issues related to science or behavior of science, or the way scientists tend to solve big problems that may impact at the social levels. The most recent one was run in 2021, just at the end of the pandemics. And this is the title, European Citizen Knowledge and Attitudes Towards Science and Technology. And I would like to discuss a little bit about this with you, because I think this provides us with some very interesting information that may somehow drive our behavior towards the correct attitude to adopt in our way to explain what we do to ordinary people that are not experts. So there was a section into this barometer, which was section 5, and particularly if we look at some questions in this section, which is related to citizens' engagement in science and technology. So basically in this section, there were questions related to interest for science and technology from ordinary people, impact of science and innovation, the level of information and attitude toward science. And of course, the survey was addressed to scientists, politicians, policymaking, but also children, young, adult, elderly, ordinary people. And therefore, the kind of responses we get are a 360 degrees kind of approach to what we should know and really think about. So if we, for instance, take this question about how do you think decisions should be taken when discussing science and technology? We can see that 52% of the response declared that scientists should take decision, but the public should always be informed about this decision. So citizens want to know what's going on, and they want to somehow be informed. And 32% also answered that the public should be consulted and public opinion should be seriously considered when taking this decision, which in the end will mean where to address the money, what are the topics and the area that are of bigger interest than other. And this other question basically addressed to, they made more specific questions, okay? Such as, although the 72% thought that science and technology related decisions should be based mainly on the advice of experts, there was a 27% of the people which was interviewed that thought that decisions should be based mainly on what the majority of the people in the country think. So they do not agree on the fact that if the population do not agree in general onto a certain position, which contrasts decision taken by experts, well, this shouldn't be taken into consideration. And another question that was quite interesting was, do you think that non-scientists should be involved in technological development assessment? And do you think that science and technology should respond to these needs, value, and expectation that comes from the society? And there was a vast number, above 50%, 50 something percent, that strongly agree or tend to agree to this opinion. So if we go even further about which are the best qualified people to explain the impact of scientific and technological development on society, as you can see, over 60% of the interviewed answered that scientists working at university or government-funded research organization must take care of this. And so this clearly shows that although people encounters problem because, as they state, because of lack of time, lack of knowledge in the field, lack of interest, lack of information, of course, they think that they should be informed, and we are the ones that should take care of it. So this is leading us to an important point. Why then is public discussion of science is so important? Well, first of all, because people ask for it. So, and I think they are entitled to do it since they pay for most of it, because they are taxpayers, and all our funds, or most of our funds, comes from basically their tax. So they are entitled to know where this money goes and what is it used for. Do they agree on the final destination of this money? Of course, their acceptance of anything which is innovative, which is trendy, must in some way be also economically important. So we have to make sure that it's a joint accepted somehow idea, because in this way, that idea, that approach is empowered. And of course, they are voters, so they need to make informed choices on at different levels, including science-based problems. There is also another aspect that I don't think must be overlooked. And this is clearly related to the fact that if we tend to keep science to our laboratories and we don't make it accessible to public opinion, then somehow this lack of information can create fears. Of course, it will create emotions when people are exposed to new trends, new expectations, and it creates opinions, but somehow opinions can be based on non-correctly informed issues. So this is another aspect that for sure needs to be considered. And I like this citation from the Global Governance of Science. This is a report. It's not recent. It's from 2009. But it says, as science becomes more ubiquitous, it becomes a victim of its own success, placed under greater external pressure to reflect consciously on its political, economic, and cultural context. So I think that trying to provide a correct, transparent, accurate information about whatever happens in our laboratory, it's important, it's crucial, because this will make our advancement accessible and understandable to the people that finally pays for it. So what is the role we can play as scientists? So I would say that our rule number one would be make ourselves available to the public. So take part in events that give an opportunity, public event, that give an opportunity to explain the potential implication of the research where we are carrying out and its possible implication in society. And try to get better to make what we do simpler to understand, and why is it useful and why we do it. So basically, a correct and more formal way to say it is to produce a science and technology literate workforce and to enable citizens to play an informed role in their democracies altogether. So having said that, okay, we have to think of key points. So how are we going to do this? What are the different strategies that we can pursue in order to communicate science to the public? Of course, you know, this is our style. The way we communicate science to general audience is publishing paper. But of course, papers, specialized papers, are read by specialized people. So this is not enough, because this will maintain the information in a kind of very restricted elite listener, and which is not involving everyday lives people. So we have to think of different ways to communicate, and also to think of a different style, because the style we're used to is not the correct style, or better, is the correct styles in our environment, but it's not the correct style in a non-expert audience. So anytime we have opportunities for visibility, we have to consider communication channels as an opportunity, as a possibility to show how useful and how full of positive perspective what we do can be. And where are all these opportunities? Of course, we may think of different models: online website, media, including in this both traditional media and social media. Of course, newsletters, publications, but also more easier opportunities that I would like to tell you about by the end of this presentation. So online website. Of course, most of our laboratories have websites. We tend to use them in a very specialistic way, but we don't have to forget that website should also have a section which is dedicated to an official relation to ordinary people. So, for instance, I found at least that it is very powerful to include success stories from the group, which would be appealing for a wider audience. It must, of course, be clear, non-specialized message, maybe relevance to certain policy or have somehow a societal impact. We don't want to write a romance. We need just a very concise and catchy paragraph. In general, according to the media rules, I found that the most catchy would average around 500 and 700 words, not more than that, with very practical facts and figures. So why is this story so interesting? Why you would bother to read it? How would this impact on your life? Okay. And also, besides success stories, in the website, we probably think very carefully of news release. So update on what's going on, even shorter than the one we discussed above. So even 150 or 200 words is enough, but it must be newsworthy. It must be relevant, and it must somehow impact at a wider level on some societal or policy-related aspect. And here we come to press releases. When we do something important, at least something that matters to us, to our laboratory, to our project, having a press release is a good idea. But there are a few rules, again, that I learned along my career. Have a catchy heading, short and getting to the point, with a small subheading where we, however, state who is involved, where is this done, when this happened, why has it happened, and how. And it must be, of course, if possible, with high relevance, but of course, we are not always doing something exceptional. Even if it's something of a lower relevance, we have to try and make it interesting and attractive to the public, to the audience. And this is, again, the area where we involve media, mostly traditional media in this respect, and we will briefly discuss about social media as well. But I would like to remember here that we need, in this instance, some very specific communication models. And the typical communication model that we should use in trying to reach the public is officially defined, was formally defined as the inverted pyramid. And the way we use the inverted pyramid will allow us to communicate effectively with the media and through the media. What do we mean by inverted pyramid? Okay, we are used to write scientific abstracts. And of course, we are very good at writing scientific abstract, but this is not the kind of things that people read. Okay, scientific abstract will have the methods, the result, a small paragraph on the top with the problem in the context, and the results in a wider perspective at the very end. This is the general structure of a scientific abstract. And this is just an example among the billions of abstracts that we have. And as we can see, for instance, this is a study where the two pathways of hate and love do correlate and interact in the frontal gyrus of the brain. Okay, so two distinct patterns of activity, romantic love and negative hate, that shares communal area in the brain. Okay, this was a scientific abstract. people wouldn't probably bother to read anything like this. They do not care. Although the problem here is interesting because it speaks about romantic love, which we all are very keen to, and hate, which is also very human. So both are feelings that are deeply human, and they would for sure attract our attention. So in the inverted pyramid, we are giving the general public the information in a reversed order. The general perspective, the key message, who, what, where, when, possibly involving people, giving a real story that involves people, that make things real, okay? The methods and all other scientific details or definitions are completely uninteresting for the public. They couldn't care less. Okay, so are the results when expressed in a technical way. So the focus we have to give is a completely different approach to the way we use to provide the information. So, and this is the same news built for the public. So what would be the final sentence in the scientific abstract here is the beginning of the news. The Proverb tells us that there is a line between love and hate, and news scans of the brain-hate circuit that confirms similarities between the two powerful emotions. So this attracts people to read it because they say, oh, let's see, how does love and hate interfere or interact in the brain, and so on. So here, as you can see, the information is built as an inverted pyramid. And then there will be a story. The story is Emil Secchi from the University of College of London, who made blah, 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 involving romantic and maternal love and all this story. And this, of course, does attract the reader to stop and, you know, continue reading. Then, of course, the details about the putamen, the insula, the different structure in the brain is absolutely, you know, final in the article, and also probably the reader will completely forget about this in 2 minutes. But the reader will remember about how the two circuits, hate and love, cover communal circuits and communal territories in the brain, and you know, the overimposure of you know, feelings like love, but jealousy, distress, and so on, which are very human and that for sure are appealing to all the readers. So basically building the inverted pyramid about what we do. So create a climax, what the people must know, add a body with information, and then just at the very bottom of the pyramid, the details, which are completely non-important for the ordinary reader. This same part that to us as scientists would be the main part of what we are interested in, knowing the details, the specificity of what we're studying. But the approach is completely different. And if we would use this, this would be completely boring and people would drop and stop reading after 5 words. So in general, I could say that there are a kind of different steps that must be followed. So what are the consequences? Why knowing or discovering this has some importance? Why, basically, why are you spending my money, okay, in this research? And how new is this? What has happened in relation to this before? Is this the first time? Is a first time news, or is something which is pretty, you know, boring? And how does this affect and changes in general in positive, but it also maybe in negative, lifestyle? How rare, how specific, how very good you are when you are doing this. Are you really carrying out something which is unique, which is very cool, which is very important, okay? And keeping in mind a perspective, a people perspective. So how does this affect real people, and how would they react to it in real life? So in general, it is good to build a frame, so in a way introduce a big question, a big issue, create interest. And then also always use real stories, anecdotes, aspects that makes the initial frame, the big question, human, based on everyday conditions or stories. Examples, give numbers, 1%, 20%, 50%, what's the impact? And create keywords, slogans. So in a way, how would what we do run in a kind of standardized keyword system that would refrain in the ordinary people mind. Of course, this is good for media, for traditional media, so or any form of scientific press, and this is good for at the EU level, international level, media with national and EU relevance. And in this instance, we will use all the kind of communication models that we have been just summarizing in this last 10 minutes. And this will even be better and will have an even bigger impact when we think of applying this approach to social media. Because with social media, numbers do change. And although we tend to be in general pretty snob on the use of social media, we have to confront with the numbers that are involved and the features of social media. So basically, why using social media? Well, they are obviously on the forefront. They are real-time, fast, mobile. And we don't have to forget that 20% of the people that uses social media are below 35 years of age and comprise between 35 and 44 years of age, which technically speaking represent the super producing ranked group of people or layers of people in the society. Social media have got incredible power and advantages. They allow to connect to anyone, peers, but also students, journalists, policymakers. Why not? Policymakers will be involved in decision. And of course, they are mainly low cost. While very often, in order to make publications on high impact news paper, journal in general, or even in new media, traditional media will imply costs. Here, the costs involved are virtually none. I mean, this is just a list of the main one, but of course we can discuss about the many other. I'm not going into all of them. But for instance, let's just give a look at the impact of X. Well, I mean, all of us know that officially Twitter, ex-Twitter, and known as X since July 2023. In X, we provide short instant messages. 200 million registered users. So these are real numbers because I mean, it's no jokes. It's 200 million registered users and an average of 1,200 posts per second. You probably experience when you are trying to find a post and you just change, you go back 2 minutes later, it takes you half an hour to go back to the original post because in the meantime, at least 100 posts have come out. And this just gives you an idea of how fast everything is proceeding. And the other interesting thing is that statistics suggest that 182% more mobile users have been registered over the past year. So this means that people, of course, use mobile to go on X. So this means that this is an exponentially growing market. And also, probably we also have to keep in consideration their relation with Google and the possibility to amplify the information through Google as well. So why should we post on X? Well, policymakers, stakeholders, journalists, they are all keeping an eye on X. Not personally, probably. They have teams that take care of it. All the very important person, from the very important ones to the very simple ones, they monitor information running on X. And of course, I can see it on everyday basis. Beside these people, you can reach scientists, you can monitor and learn, you can build community, you can create a number of initiatives, you know, gateway to further information, micro and macro blogging, and all sorts of different activities that we may access through X. And yeah, I mean, these are just pictures taken here and there from X posting, and these are all policymakers. I didn't include the Pope because I thought that there might be some religious drawbacks or objections, but I mean, the Pope has a very lively X postings equipe as well. So this means that it is evident that this is a way to engage, and policymakers are for sure good at this, and we have to keep this in mind, because in the end, these are the people that make decisions, these are the people that influence everyday decision in our country at the level of the European Union and in more in wider conditions. So this is something that we have to keep clear in mind. Facebook is another options, of course, with the very well-known like page. It's a kind of community building, probably slightly less immediate than X, but with a viral effect. Certainly, it's interlinked with other media sources, such as Instagram, and it has a great potential as well. So I think that we shouldn't overlook in our projects, in our laboratory, to have a solid a Facebook page as well, where, you know, we share information and we try to reach whoever is interested in opening the page and read it. Wikipedia is also something that we should consider. It's de facto the encyclopedia for young. People don't go and read the encyclopedia anymore. When you don't know what you're talking about, you don't know a term, you don't know a process, you just open Wikipedia. And this is worldwide. It's the starting point. Roughly, slightly less than 100,000 active contributors, making all the contribution available to the community. And of course, this ends up with an increase in your ranking in research. And it's quite simple to set up. I myself, I think with Aliresa's help as well, we set up Wikipedia entries, for instance, on a project that Aliresa was sharing some years ago, and we introduced this entry in Wikipedia. So this is just to give you an idea. So you basically prepare an information, you adequately write whatever you want to include in it, and then you will be in the Wikipedia free encyclopedia forever. And this is also something that may be quite powerful and solid in terms of the kind of information we want to share with the public. LinkedIn, well, we are more keen to use LinkedIn as scientists. In 2024, 1 billion professionals user worldwide. 20 million only in the EU. And it has been estimated in 2010, these are the last information that I found, 2 billion people searches. So I think that this is more likely to be something that we are used to access in relation to discuss with colleagues, to empower our career, or to get answers when we ask a specific question to specific person or to specific groups. However, this is more likely to provide information within very distinct circles of people than reaching the ordinary taxpayer. But at the same time, we shouldn't underestimate this, because this is a way that is, for instance, useful to reach, as Fulvio was telling us in the previous talk, maybe investors, people that can imagine fanciful and powerful applications of your findings, your experiments, your paper. And so for sure, this is a more kind of niche use of social media, but it has got a specific target as well. YouTube is something that is very powerful. It gives us the possibility to prepare video. Of course, you have to be very good at preparing video. But if you are, I was astonished by reading that 2 billion video views every 24 hours on YouTube, which is, these are numbers that cannot be even dreamt about in traditional approach in terms of communication. And more than 24 hours of video uploaded per minute. So these are statistical numbers that can be found when you do search of this. And this, of course, is very impressive, because somehow can lead you to create a channel of your own, inspire, nourish creativity, represent a showcase to the work you are doing, to the world, open. And this again is a way to climb and improve your position within the Google's ranking. Okay, we can also think of more traditional aspects like preparing leaflet for non-specialized audience. And this can be a good strategy. It depends on the context. It can be interesting when you visit fairs or you visit other area where you don't have too much time to think, but to talk, but you want to leave something to distribute to the public. Of course, our classical dissemination events, experience are talks at conferences. We are used to do that. That's not difficult. That's a piece of cake. Posters, even more simple. You don't have the stress. You just hang the posters and stand there and wait for questions. But of course, this is very tight and specialized. Something which is very interesting is create events with or in schools. This is something where you can really foster the interest of younger audience for specific problems or specific area. And the other options that we may think are events in public spaces. And I will give you some examples of this. Similarly to the participation to science festivals, which I think are also very are also very promising and interesting. So the idea here is to have the correct tips and techniques to communicate to this very variegated and specific target of audience. But the general idea is, I'm also a scientist, but please get me out of here, meaning to the lab, and bring me there, bring me to discuss with you. So, of course, talks are the very classical ones, and I'm not going to use my time for this, because we all know that's our preferred system, isn't it? Going to conferences and discuss with peer scientists and communicate science in a very traditional way. But, of course, this is very specialized. Posters. We know how to build posters for an academic style. This is the standard style, but this will not work for the public. This is completely uninteresting to the public. So posters that we might prepare for the public must have a very specific graphic and textual style. And these are thought to attract the attention. Very, very few words, very, very graphic, something like this. And this will attract people. This is a poster, but this is a poster that really touches people about feelings, about memories, about other aspects. And it is completely different from our approach to posters. Events in school. School ambassadoring is something which is hugely recognized by the EU. And you can apply to be a school ambassador. And yeah, you can integrate your scientific knowledge, trying to engage with very young people and to stimulate their interest and foster their motivation for all the scientific problem that you might be interested in. Of course, this requires a certain skill in communication, because interacting with young children is not easy. It's a completely different story. But of course, it's very interesting. I'm not going into this, but I have found a number of information on the survey when they asked children about what scientists are and what they think scientists are and they look like, and apparently, for instance, a big majority of them would identify scientist image with the stereotype Einstein image we have of Einstein, which is very interesting, because probably they don't even know who Einstein is since they are 7 years old. But for some reason, there are some commonplaces that are conveyed. And it's also interesting to see that usually when these young kids belong to families where there are scientists, especially mother scientists, they have a completely different feeling and a much more distinct perception of, for instance, science and research. So this is again showing that they are there. They are only there to be reached and to be informed. Events in public space can also be a great opportunity to try and involve citizens. They allow interaction, face interaction between the scientists, the scientific group, and audience that can be different. So these opportunities can fall within larger events or can be created purposefully for this reason. For instance, you can use museum, corners in a museum where you ask the permission to show your own, to share your own information. Or something which is very, very enjoyable is café scientifique or science cafes. So you take agreement with a bar, with a cafe, and you organize a special initiative. And, usually people are sitting there and they will discuss, and you will try to raise interest to discuss about a certain problem. So sometimes you start with very provocative questions and you try to stimulate reactions. And usually a nice atmosphere is created, and Café Scientifique are really a very nice experience, actually, not only for the ordinary people, but for the scientific group as well. And one opportunity for this, for instance, is the European Researchers' Night, which involves very many universities throughout Europe. Usually is at the end of the summer. And this is a kind of every single university do organize fairs, organize initiatives for that, and you can try to have opportunities within that and present your results. And usually you have a small stand, and yeah, and then it's only your imagination. You have to think of something that may catch the attention of people. And usually it's very pleasant because it's in the late afternoon and early evening, and it's a very pleasant environment. So most of the EU member states do take place in this Researchers' Night, and change the name of these initiatives do change along the different years. This is, for instance, one we took part many years ago, but this was a very nice one, very big one. It was held in 2012, and the name of this Researchers' Night, or the title was Meet Me Tonight. So face to face with research. But every year the theme slightly changes, but in general the possibilities are endless. Yeah, we were at the time participating as Center for Stem Cell Research, and for instance, we had quizzes, competition, and we had young children participating. Young scientists were involved, and basically it was young scientists with young children interactions, trying to make it as smooth as possible, and as not formal at all. So we would be using senior students or very young scientists. And we also had a Café Scientifique, which in that case, being summer, involved mostly gelato, being in Italy, and which was also a very nice initiative, and involved many people. And the area was a big park in the city center, and there were representatives from most faculty in the university. And these are just the snapshots showing how crowded it was, showing how interested people are in trying to understand how things work. For instance, I don't know, there was these things about chromosomes and stuff, and of course people would live with memories and with information. And I mean, in that instances, for instance, we had 16,000 people visiting the fair, which is really a considerable number. And I mean, the possibility, look at this is an impressive image of the events that was taking place during the evening in this very nice environment by the park. And it was a very communal idea of sharing information to extend the general knowledge about science. So I will just conclude with 6 good reasons. So 6 good reasons that I would like to share with you to conclude this small discussion, and especially I hope I have convinced you about the opportunity to disseminate within your project. So not only excellent results, scientific excellent results, but also sharing these results, explaining these results, and trying to explain why these results could have an interest for ordinary people and for the society in general. So as a first reason, I would for sure mention that we owe the people to give information about the experiments, since they pay for them. Through the tax, they pay for what we do in our laboratory. And for sure, in this way, we can, the good reason number two is that by doing this, we can leverage our skill as a scientist to inspire critical thinking in public as well as in a political setups. We as researchers occupy a high responsibility position to somehow control the flow of scientific misinformation that may come from the media. So providing a transparent information of what's going on in our lab will prevent any misinformation that may derive from not giving information or from letting people inform in a non-prepared and basically using an approach which is not based on solid knowledge, but rather, more journalistic one. And reason number four, of course, is that by doing that, we somehow have the opportunity to explain how what we do can improve society, can improve law, can improve regulation, can improve in general what happens in real life. Of course, we are the most adequate people to explain what science is and, above all, what science is not, which I think very often can be misunderstood. And last but not least, we find in the fantastic position to share with the other, to discuss with the other, the beauty of the world, what we know about, all the natural phenomena around us and inside us. But at the same time, to implement research and funding in a certain area, in a certain direction that may play a very important role within this universal beauty which is around us and perfection inside us. So, although all this may be very far from our everyday activity, dissemination matters. And I think we should really keep it in mind, because this would make our approach to science and to the way we are in a more complete 360-degree personality in terms, and I don't mean personal personality, but laboratory personality and identity. It will just enrich what we can offer from our own identity. And with that, I would like to thank you, and I hope you are not too bored, and I hope you are eager to run out and provide people with any information as possible. Thank you for your attention.
Thank you very much, Tiziana. It was very inspiring. And personally, I got many inspirations, like what and how we could implement and improve in the projects that we have here in at our university. And also we have already first question from Christina that I will read, and in the meantime, if there are more questions from the audience, please raise your hand or write them in the chat. So Christina wrote, thank you for the interesting insight to the subject. I would like to ask your opinion about the future of X. Could it be that the latest developments, considering Elon Musk as Donald Trump's administration member in future, can have a backfire to the popularity and seriousness of this channel? There have been first signs of this tendency in Estonia, although it has never gained such popularity in our country that in some other regions worldwide. So very up-to-date question. So what would you say, Tiziana?
Well, thank you for this question. Of course, you know, we don't know. We don't know what's going to happen because in a way, X had been looked for a certain while as a social media channel that would filter information at the lower level than others. And this was very evident in a number of very tragic events of the last year, where we could get informations about what was happening in certain war countries or stuff that appear to be more open from X than from other social media channel. Now, yeah, I don't know. I'm just standing by because of course it appears that there is a very how to say, strict connection, that's what I can say until now, with very distinct political forces, which of course would put the situation in a more restricted perspective. This is, but it will be interesting to see, and it will be interesting to see how people will react to that. Because, I mean, social media, I think, are extremely quick system. They are very fluid. So you can gain and you can lose very quickly, depending on what's going on. And depending on how you are dealing in terms of administration, of course, I mean, with the freedom of information, because I think that one thing that we have seen in many different examples has been that social media could not be stopped. So although all the information that we had through television, through other information, more classical media channel, were obviously filtered through one way or a different way, but it was very evident that we probably never really got the story, you know, in its complexity. Social media somehow appeared to manage to overcome these controls, and even, you know, with, you know, certain very quick events like putsch or things like that, you would have people communicating through social media, giving information, spreading information completely out of control, you know, out of the official restraint. Now with X is very, yeah, it's very fluid. We will see. But I think that if it would turn out that the information is more sternly controlled, what I can imagine is a quick loss in terms of interest. People will shift to, I don't know, other, you know, other social media channels, or, I don't know, TikTok or whatever, you know, anything which is running wild, you know, but free. That's the idea, not to have filters. And I find it difficult to think that this won't happen with X, but we have time. We will see.
Thank you very much. Yeah, time will show what will happen. It's a big question mark, I guess, for everyone for now. Do we have any other questions? Alireza, please go ahead.
Yeah, Tiziana, thank you very much. I think you are one of the best people I know that has, yeah, so much experience, and also you are very passionate about the public and about communicating. And that was completely evident in the presentation that you did, and it was very, very nice. Thank you very much.
Thank you, Alireza.
My question is, you know, compared to even maybe 10 years ago when we were doing the course and other kind of things, and so the social media has evolved. It is quite a lot of different things and different points that's coming. there. And for one, you know, even for you, for me, for Fulvio,